All right. Today, section 2D from chapter 2, we're going to add, subtract, mix numbers. Very similar to what we've already been doing. We're going to look at one extra thing here, and that's borrowing, which I know you've seen before, so we're just going to kind of go over that with a couple of examples. So how do you add, subtract, mix numbers? That's what we're going to be doing here. That's our essential question. So to do that, first thing you want to do is you want to first add or subtract the fractions. Okay, renaming them using the least common denominator if you have to. Okay, just like we've been doing. Okay, then add or subtract the whole numbers and simplify, just like we've been doing. Okay, so for an example, if you had 6 and 1/8 and you want to add 2 and 5/8, notice the common denominator. So you can add the whole number, the integer parts, add your numerators. So 6 and 2 is 8. The numerator is 1 plus 5 gives you 6/8, and then simplify. 6/8 simplifies to 3/4, so 8 3/4 is your final answer. You didn't need a least common denominator because you had one already. What if we were adding 1 and 5/9 plus 4 and 1/6? Okay, then what we would have as a common denominator between 9 and 6 is 18. So 9 times the 2 gave you 18. So 5 times 2 gives you 10. 6 times 3 gives you 18. So 1 times 3 gives you 3. Add the whole number parts, you get 5. 10 plus 3 is 13 over 18. You can't simplify it. That's as far as you go. Okay. Another example. This one with subtraction. Common denominator between 5 and 10 is going to be 10. You only need to change this fraction here. 5 times 2 gives you 10. 4 times 2 gives you 8. Now you can take the 8 minus 3, and you're going to get 5/10. 5 minus 1 is 4 and 5/10. Simplify the 5/10. 4 and 1/2. Okay. Hopefully that looks pretty familiar to you. Not too big a deal or difference from what we've been doing there. But here, now we want to have to rename or borrow. Okay. Just center it up for you here. So you have to rename or borrow when you are subtracting a larger fraction from a smaller one. Okay. If you are borrowing from 11 and 2/5, okay, just looking at the borrowing part here. All right. When you borrow 1 from that 11, okay, making it 10, you're adding 1 to the 2/5. Well, how do you add 1 to 2/5? Well, you got to go back to that common denominator. Okay, and our common denominator would be 5. So we would rename that 1 as 5/5. And then we'd add that 5/5 to the 2/5 we already had, and you get 7/5. Okay, so it becomes 11 and 2/5 becomes 10 and 7/5. They're equal, just look different. Okay, same value. And if we're subtracting 2 and 3/5 from it, whereas we couldn't take 3 from 2, we now can take 3 from 7. And 7 minus 3 is 4/5. And then 10 minus 2 is 8. If you can simplify, simplify. Another example, 5 and 3/8 minus 4 and 11/12. We need a common denominator first before you start thinking about borrowing. Okay, we don't know if we need to borrow yet. So the common denominator between 8 and 12 is going to be 24. So 3 times 8 is 24. 3 times 3 is 9. Here we go. This should be, so we've changed that one. So to change the 11/12, 12 times 2 is 24. 11 times 2 is 22. So what did I do here? Well, that's a big mess right there. That's supposed to be, what I did here is this, I can't take 9 minus 22, so to get to here, what I did is I borrowed 1 from the 5 and made it 4, but what I borrowed was 24 24ths. That's my 1. And 9 and 24 gives me 33 24ths. Now I can subtract them, and I get 11/12. I'm sorry, I'm going to get 11/24. Boy, really messed up typing that out. So and then the 4 minus 4 gives me 0, so I'm just left with 11/24. Okay? What if we're taking something like this? 7 minus 1 and 1/2. I don't have a fractional part here. Okay? So what I want to do is borrow 1 from the 7, and I want to create my fractional part here. Well, that 1 that we borrowed, what am I going to call it? Okay? Well, since this is 1/2, let me call my 1 2/2. So I'll call this 1 2/2 right here. So then my 7 becomes 6 and 2/2. There's my 1 plus my 6, that's 7. So I get 6 and 2/2 minus 1 and 1/2. So 2 minus 1 is 1/2, and 6 minus 1 is 5, so 5 and 1/2. All right. Sorry about the little snafu there earlier. Let's take a look at our last problem here, real world example. Okay, this is from page 106. Question M. Jermaine walked 1 5/8 miles on Saturday and 2.5 miles on Sunday. How many more miles did he walk on Sunday? So this is a subtraction problem. He walked more here. How much more? Well, you got to subtract those two. So 2 1/2 minus the 1 5/8. Common denominator between 2 and 8 is going to be 8. So I'm going to change when I borrow my 1 here and make that 1, because my 4/8 I can't subtract here. When I borrow, I'm going to change that 1 to 8/8. And 8 plus 4 is 12. So 1 and 12/8 minus 1 and 5/8. 12 minus 5 is 7/8. 1 minus 1 is 0. There's my answer. Okay? So as I explained it over here, there's my borrow 1. Okay? So what I want to do now is look at some examples. Now, a lot of times when I like to do these problems, I like to write them vertically. Okay, I showed you the examples horizontally across, just like the book did, but you can do the same problems just like this. Okay, so first thing I'm looking for when I'm subtracting is the common denominator here. So between 3 and 4, it's going to be 12. So 4 times the 3, 3 times the 3, 3 times the 4, 1 times the 4. Remember, I'm multiplying by 3/3, which is 1. 4/4, which is 1, so I'm not changing anything here. I can take 9 minus 4 and 7 minus 3. That is simplified, that's it. Okay? Another example. Common denominator already, but I can't take 3 from 1. So I got to borrow here, and that 1 I add is going to be 4/4. So what I have now is 2 and 5/4. Okay? See what I did there? I borrowed that 1, and when I added it to my fraction, I'm going to change that 1 to 4/4. Now I can just subtract, and I can simplify that. Boom. Okay? One more example, last example. Common denominator between 2 and 5 is going to be 10. Uh, 2 times 5, so 1 times 5. 5 times 2, 4 times 2. Add them up. 5 and 8 is 13/10. 8 and 3 is 11. 10 goes in there one more time. Add that 1 to your 11. Okay? Hopefully this has been helpful. We're going to look at more of this tomorrow and the next day in class and some application of it. We will get after it then. Okay?